once again welcome back. I hope you all are doing well. So far we have already completed the topic, the chapter that is your motion in a straight line, unit measurements, and your laws of motion. So this is our lecture number 1 of work, energy, and power. But also this topic, that work, energy, power, also we have already completed. So today I will revise from the topic that is your work. Okay, then we can go through the energy and power. Okay, so student, these are the key points. Today we are you are going to discuss that is the introduction part of work and the concept of work, that is the mathematical concept, a real formula. Okay, so students, actually we have already completed this chapter and we have solved so many numericals. So I will revise from the terms work. Okay students, so students, every day in our life we do so many different types of work, starting from getting from the bed, brushing, eating, bathing, listening, writing, speaking, and doing exercise. So many types of work. Suppose your examination is coming, then every day night you do lot of work by preparing for the final exam, and we say that working hard. Yes, all these are correct. But coming to physics, according to physics, do you think that all these things what we discuss now, that all works? Maybe no. Then what is the work in physics? What is the work in physics? What is the work in physics? What is the proper definition? Here we shall discuss. So we already discussed that any physical quantity, that physical quantity is represented by the help of two parameters. One is n, another is u, numerical value and unit. Okay, or any physical quantity which is measurable can be taken into physics. Anything which is measurable can be taken in physics. So if you want to say this is work, it should be measured. It should be measured. Then what is work in physics? We are going to discuss now. Okay, actually I will revise from the basic terms, that is your physics, that is your work in physics. So work means, so what is the proper definition of works? If you want to do any works, you apply some force, a term force, that we have already discussed in your previous chapters. That is your laws of motion, force and laws of motion. We discussed that if you want to change state of a body, so you had apply a force. So force is very important. Force is very important entity in work. So force is a very important entity in work also. So work is defined as the product of force and displacement. Force and displacement. The product of force and displacement in same direction. In same direction. In same direction. In same direction. Okay. So that is the condition. That condition, same direction, is most important. And the product of, it is the product of force and displacement. The force is symbolically represented as F, and displacement, that is S. Okay, and the work is symbolically represented, that is W. So W equal to force into displacement. Force into the product of force into the product of force and displacement. Okay, or you have to study in +2, that is a dot product. This is the dot product. Okay, force into displacement. And in your plus 2, you have studied that is dot product. So we can written as that is W equal to force dot S. Okay. That is chapter that is scalar and vectors in your plus 2. Okay. You've studied in your plus 2 that is dot product. So what is defined as the product of force and displacement? The product of force and displacement. So you have to study. You have to discuss here that what is the formula or what is the concept, what is the basic concept or what is the real formula of work. Okay, so see that condition is most important, same direction. Okay, actually students, this one, here the force is a vector quantity. Force is a vector quantity. Also S, force and S both vector quantity. S is the displacement is a vector quantity, but distance is a scalar quantity. But work is a scalar quantity. Scalar quantity means those quantity, the physical quantities which having magnitude only. Okay, so work does not have direction, it is having only magnitude. So but work is a scalar quantity. Here the force, that is vector quantity, and S, the displacement, vector quantity. But work is a scalar quantity. Okay. So here we have seen some examples. Okay. This is a scalar quantity, work is a, and we can go through its unit. Okay. Suppose it's SI unit. Okay. Force, the SI unit of force is Newton. Okay, and the displacement, that is meter. So Newton meter, that equal to joule. So what the SI unit? Joule. Okay, then CBSE unit. Dyne, force ka dyne. And here the displacement, that is centimeter. Dyne centimeter equal to arc. So SI unit of work is joule and CBSE unit of work is arc. Okay, and what is the relation between joule and work? 1 joule is how much arc? So 1 joule, that is your 1 Newton, that is your 10 to the power 5 dyne, and 1 meter, that is your 100 centimeter into 100 centimeter. So 10 to the power 5, and here we can written as that is 10 to the power 2, and 9 centimeter, that is your arc, then 10 to the power 7 arc. So 1 joule equal to 10 to the power 7 arc. 1 joule contains 10 to the power 7 arc. That is your SI unit. And here we can go through the dimensions. Dimensional formula of work. Dimensional formula, that work equal to force into displacement. That force is the dimensional formula of MLT minus 2. Okay, and displacement, that is your L. And here in this dimensional formula we have already studied. We have already completed, that is your unit measurements. That M L to T minus 2. This is your dimensional formula of work. Okay, so this is some basic terms we have already studied. Okay, that is 1 joule equal to 10 to the power 7. Now this is the relation between joule and arc. Okay, so here we have seen some examples. Suppose a person is pulling the toy car. Suppose this is a toy car. Okay, this is a toy car. A person is pulling through a thread. This is a thread. Here it is a person. So here it is a person. Okay, this is toy car. Okay, the person is pulling. The toy car using a thread, this is thread. Then using a thread, this is thread in this direction, this is a thread in this direction, and force is applied. Pulling means the force is applied towards left side, force is applied towards left side, and the car is also moving in the same direction, means the displacement, the moving means its displacement is in this direction. The force and displacement in the same direction. This is your condition, same direction. Okay, the force is towards left side, and also the car is moving in the left side, in the same directions. Okay, the displacement also in the same direction, in the left side. Then we say the work is done. The work is done by the person on the car. This is one example. Here so many examples are there, and we have already studied so many examples. Okay, just I will revise. Okay, so both the force and same are in same direction. Both are in the same directions. Now we shall focus. We shall focus its mathematical formula. How to solve in numericals. Based on finding the work. Okay, the same direction, the force and displacement are in the same direction, means then we can say that the work is done. So students, how to solve a numericals, how to find out the work. Okay, then we shall discuss the real formula, the real concept, the mathematical concept. Suppose you do lot of works, but this is not actual work. In physics, this is not actual work. The work is only said to be done whenever there is a force and there is a displacement. Suppose I apply a lot of force on this blackboard. Does not displace it at all. Doesn't move at all. So the work done by me, according to physics, will be 0. Though I am standing and lot of energy I am pushing it. I am getting adjusted. But according to physics, the work done is 0. So work is force into displacement. Here is the dimensional formula, and this is from basics, some examples. Okay, so suppose we do a lot of works. Okay, and here we shall focus on the real formula. Okay, just simply write in your rough copy. All of you open your notebooks and NCERT books. So now we shall focus on the mathematical formula or real formula. What is the real formula, real concept of work? Okay. So students, so here the unit of work, that is SI and CGS, 1 joule equal to 10 to the power 7 joules. Okay. So students, till now we study that what is the formula for work. That work equal to force into displacement. Okay. So work equal to force into displacement. Now we are going to find the work by using the formula. Very simple questions. Suppose this is a body. Okay. One simple question. This is a body, and the force is 10 Newton, and the displacement S equal to 2 meter. So find out the work. Here you see that force and displacement are in same direction. So what does equal to force into displacement? So work equal to 10 into 2 Newton into meter or joule, that is 20 joule, means work is 20 joule. Simply this is the simple questions. Okay, suppose we will see the earth revolves around the sun. So what is the work done in a round trip? Okay, suppose another questions, question number 2, this is question number 1. Here this is sun and this is earth. The earth revolves around the sun in a round trip. In a round trip. So what is the work done in a round trip? Is the questions. Simple basic questions, conceptual questions. The means in a round trip means the earth leaves its position and returns back. So you see in a round trip what is the displacement? This is the initial position and here we will start the earth revolves around the sun and comes back to this given position. So what is the displacement? The displacement is round trip is 0. The displacement is round trip is 0. The initial position comes to back its initial position. The displacement is 0. So in a round trip, what is the displacement? The displacement is in a round trip is 0. So how? The displacement is the shortest distance between initial and final position. So when Earth returns back its initial position, so then what is the displacement? The displacement is 0. Then what is the distance between the initial and final position? Now there is no distance between them, so it is 0. So the displacement is 0. Displacement is 0. Keep in your mind. So hence this is the very important. W equal to, that is F into S, and displacement is 0, that is W equal to 0. W equal to 0. So what is the displacement? The displacement is 0, and we have to put in this formula, that's W equal to 0, water is equal to 0. Means so no work is done when Earth revolves in a complete cycle, in a round trip, in a complete cycle, in a round trip around sun, because the displacement is 0. Okay, so this gives a very good analogy. Suppose here this is साइकिल, एक साइकिल है, ठीक है, और आप साइकिल वहां पे फोर्स लगा के एक इनिशियल पोजीशन को रनिंग किया, इनिशियल पोजीशन जो है फिर कम्स बैक टू दिस इनिशियल पोजीशन, तो व्हाट डन इज 0. Okay, so this is not the proper explanation for this particular questions. These questions are revolves around the sun. So see here we will see the real formula, real concept we will study now. The work is equal to force into displacement. The work equal to force into displacement. This particular questions, force into displacement into cos theta, cos of theta. अब सभी लोगों को मालूम है थीटा means angle. Okay, so actually this real formula, that is the force into displacement into cos theta, means W equal to Fs cos theta. W equal to Fs cos theta. Okay, so suppose this is a body and the force is applied in some direction, the force, and the displacement is in this direction, and now this is the angle, the theta, the angle between the force and displacement. The angle between the theta is the angle between force and displacement. The force is applied in some direction, okay, and the displacement takes place in this direction and some other directions. So angle between the theta is the angle between force and displacement. Then what is the work done? That is W equal to Fs into cos theta. W equal to Fs into cos theta. What W equal to force into displacement into cos theta. So cos of the theta, that is the shown mathematical ratio. I will give its value. So वैल्यू मैं दे दूंगा, ठीक है, वैल्यू को सबसे पुट करके हम न्यूमेरिकल्स फाइंड आउट करेंगे, ठीक है. तो दैट इज W इक्वल टू Fs इनटू cos थीटा. सो दिस इज द थीटा इज द एंगल बिटवीन फोर्स एंड डिस्प्लेसमेंट. देयर इज a body, that is W equal to Fs into cos theta. This is the real formula. Okay. So the value cos theta. Suppose here we will see the some special cases. The work is done. That is your first case positive work done. Second negative zero work done. The third one is your negative work done. Okay. That force W equal to force into S. This formula also correct. This formula also correct. And this formula also correct. But this formula in particular condition, which condition? That condition is W equal to Fs cos the angle. Here we will focus the angle, the theta angle between force and displacement. Suppose the force and displacement are in same direction. Here is a body, but the force, first case, that force is vector quantity, also displacement, and force and displacement are in same direction, mean parallel, in parallel directions. This is the parallel direction. And here theta equal to 0 degree. Parallel condition, theta equal to 0 degree. And W equal to force into displacement. So here W equal to Fs cos theta, and theta, that is your 0 degree, then cos 0 equal to 1. Cos 0 equal to 1. And here we have to put that 0, cos 0 equal to 1, then W equal to F into S. Okay, means that is your positive work done. That is your positive work. W equal to F into S. And second case, 0 work done. Second case, 0 work done. 0 work done. Suppose this is the earth, or the earth revolves around the sun. This is your sun. The earth revolves around the sun. Okay. So actually second case, the concept that force is in the direction and S is in this direction, or the angle between force and displacement, that is your 90 degree. So W equal to Fs cos 90, or cos 90 value, that is your 0. Here you have to put that is your W equal to 0, means no work is done. Or this questions in previous we will study that earth revolves around the sun, the work done is equal to 0. That question is based on this second case. Suppose the earth is revolved around the sun in a round trip. Okay, the work done is 0. Suppose we consider now see the earth is attracted by the sun like this, okay, due to the gravitational force. The force is the gravitational force. The force direction, that is the force direction. That is your force direction, gravitational force. Then what is the direction of displacement? Here the earth, the displacement like this. Suppose here the earth, the displacement like this. Here the displacement like this. Okay. Suppose here the earth, and we can consider in half trip. Suppose you can consider half trip. Actually, in a round trip, that work done is 0. So suppose you can consider the half trip. Okay, you can consider the half trip. What is the work done? The original concept. The W equal to Fs cos theta. Or due to gravitational force, the sun pulls earth towards the the sun, because the sun pulls earth towards itself due to the gravitational force. Okay, suppose we can see or we will consider this is the heart. Okay, so what is the force over here? This is the force over here. Okay, so towards the sun the force is like this, and S always 90 degree. Here also is 90 degree. So always 90 degree. So W equal to Fs plus 90, that is your W equal to 0. So in the heart rate, suppose this point or this point, in this condition, at each point, the watt done is 0. In half of the tree or in a round tree, suppose I will ask you questions, 1/4 trip or quarter of trip, 1/4 trip or quarter of trip. What is the watt done? That watt done also 0. So here you have to keep in mind, at each point the watt done is 0. Okay, 8 points in the watt done is 0. That's W equal to Fs cos 90. This is the most important concept, original concept. Always 90 degree. Okay, so how much angle? Always 90 degree. Then third case. Suppose this body or the force is in this direction and the displacement is opposite to the direction of force. The body moves in the direction of opposite direction of the force. So here theta equal to 180 degree. Theta equal to 180 degree. That is okay. Suppose here third case. So the body, the direction of force like this, in this direction, and the displacement is opposite to the direction of force. So W equal to Fs cos theta. This is the direction. Opposite to means theta equal to 180 degree. The force and the angle between force and displacement 180 degree, or cos 180, that is your -1, and W equal to minus Fs, that is your -1. And here that the angle between force and displacement, that is your 90 degree, or cos 90 equal to 0. Okay, so this is the -1 term, third special case, third case. And so many values are there. Cos 0 equal to 1, write down. Cos 30 equal to root 3 by 2. Then cos 45 equal to 1 by root 2. Okay. Cos 0, 1. Cos 30 root 3 by 2. Cos 30 root 3 by 2. Cos 45 degree. Cos 45 का डिग्री का वैल्यू 1 by root 2. 1 by root 2. Then cos 60. Cos 60 का वैल्यू है. Cos 60, that is for 1 by 2. Okay. That cos 90. Cos 90 0. Cos 90 0. Cos 0 1. Okay. Then cos 120. Cos 120 minus half. Cos 120 minus half. Then cos 135. Cos 135 degree minus 1 by root 2. Okay. Then cos 180 minus 1. Cos 180, that is your minus 1. Then cos 270. Cos 270, that is your 0 degree. Okay. Then cos 360. Cos 360, that is your minus 1. Okay. Sorry, cos 360, that is your 1. This is the value of cos. Here we have to put ends on the numericals. Okay, I will give some questions or some assignments on the basis of this real concept formula, W equal to Fs cos theta, W equal to F into S. I will give some questions and we have to solve the numericals. Okay, so try to understand the concepts. Try to understand the concept and keep in your mind the formula and conditions. then we'll solve so many numericals. We have to solve. Okay, and numericals problems, do more, solve more numericals. You do not don't have the face of any solving the numericals. आराम से हो जाएगा न्यूमेरिकल्स. कॉन्सेप्ट याद रखो, कंडीशन याद रखो, न्यूमेरिकल्स प्रैक्टिस करो. प्रॉब्लम प्रैक्टिस करने के बाद खुद का प्रॉब्लम सॉल्व हो जाएगा. ठीक है? ओके स्टूडेंट्स, तो दैट्स ऑल फॉर टुडे क्लास. ओके, इन द नेक्स्ट क्लास वी हैव टू स्टडी, you have to revise the energy part. Okay, so that's all for today class. See you in the next class, and we have to study in our next class, that is your energy part. Okay, kinetic energy and potential energy. Okay, so stay safe you all. Thank you.